So it's my great privilege to introduce you to the true luminary in the world of programming languages, Mr. Udyan Verma. With over 2 decades of experience in the field, Udyan is a revered figure who has left an indelible mark in the industry. Udyan's mastery over multiple programming languages and his exceptional problem-solving skills have earned him a distinguished reputation. His contribution has extended beyond coding. He holds 2 patents that highlight his innovation spirits and his ability to turn ideas into reality. So as we embark on this journey into Python programming, let's remember that we are learning from a true veteran and an expert. And feel free to ask questions. And if there's any homework, please try to do it. So please join me in welcoming Udyan Verma. Over to you, Udyan.
Hi guys. Okay. So before I start, I want some of you explaining me what do you understand about what actually is computer?
Computer is an electronic device that processes and stores information. It performs calculations and executes tasks based on instructions given to it.
So it started around 50 years back, and now whatever the computation power which was there 50 years back, 1,000 times more powerful is our mobile phone. So technically what they have done is they have taken a computer which used to be 3 to 4 story building 50 years back now into a small watch or a mobile phone and laptops, anything whichever you see digital is actually is a miniature computer or even a bigger computer you can think of. But the idea here is how can we do faster calculations. It's all about calculation. Whatever you see in a computer is just a calculation. How calculation is perceived by us, you feel it is a screen, or you feel it is a audio, or you feel it is a basically some printouts or something. The idea is you have a calculation and they use some kind of transducer which translates the digital information into a physical entity, or they use bits to switch on and off some bulbs, and you have millions of bulbs in your screen. So when they switch on and off, you see a picture. So idea is it is all about calculation, nothing more than that. Computer does not understand anything. At this point of time, whatever we see in the form of AI or something, it is again a calculation. It itself yet do not understand that this is a physical object or a digital object. It just calculates. So all in all, it just calculations. Our calculations, whatever is the outcome of the calculation, is perceived by humans. For example, a sound, if we have a receptor in our eyes which can feel the vibrations of a sound, we will be able to see through our eyes. Something like bats. So the idea is we have built computer in different forms. For example, a mobile for a dedicated, but it has more capability than a laptop. But we have a laptop which is much more powerful than a phone. So what we are trying to do is we are trying to build different devices based on a same processor or same set of devices. It just we give something more power and something less power. Why do we need programming? What is programming all about? What we should understand is if it is all about calculations, so all we have to do is give it instructions. As some of you said, that it is just an execution of some instructions. And these instructions have to be some kind of a logical way of presentation or giving it to the computer. So that's what we have programming on. Before even I go for programming, I would like to share that in order for you to learn programming or do anything on your desktop, you technically do not have to install anything on your desktop. If you want, you can, you may, but you don't need anything. Nowadays, we have quite a few websites which are actually allowing you to do programming inline. I'm assuming some of you have some idea about programming, and most of you do not have much exposure to the programming. So what are we trying to do using programming? So for example, if you want to display something on the screen, you have this print statement, which is a programming construct. Or if you have some numbers to multiply, then you multiply two numbers. For example, x is equal to 20 multiplied by 20 or 201. So this is how we actually interact with computer. What we do is we give it a list of instructions. Those instructions should be understandable by the computer. So now what happens is, in general, you have this CPU, which is a computer, we call it central processing unit, and you have these instructions coming from here, like a program. Some people wants to get their hands dirty and some do not want to. So if somebody is very technically, who understands what is actually happening in the background, and I want more control, they will use programming language like C, assembly, and if they don't care what is happening at the background and they just want to do something what more common, then they prefer Python. There are some intermediate states as well, which is you want to have control, but you still have other aspects. For example, you have some object-oriented or programming like C++. There are some programming languages which are dedicated for their storage. So if I show you what technically a computer is, it is like this. You have a desktop or a computer or a laptop or a mobile phone or a watch or anything. It will have some kind of storage. It could be a physical storage like a spinning disk or something, or it could be digital or digital. I mean to say it's like a SSD, solid state devices. And then you have RAM. RAM is all about temporarily when the computer device is on, where do you keep it temporarily? Motherboard is basically, it's like a frame of your car where everything is assembled on the top of it. So it is holding the tires, it is holding the engine, it is holding everything. But it in itself is only one responsibility: to distribute power, to distribute data from one part to another part. And that's the motherboard all about. It may have some other capabilities, but all in all, motherboard is all about connectivity. So now we have these programming languages, we have this Objective-C, which is dedicated for the database. Suppose you want to store something, we have this Objective-C. This C++ is specific to certain kind of application development, but it's more versatile than any other programming language. So now what happens is, generally people don't care what we are, how we are storing it, how we are processing at the bank. They just want a very high level language so that they can do the job. And that's why we have Python in the picture. Okay, so now I'm going to give you some sample. For example, you want to print something, so you just execute. I will say print, I execute. This is sample. Now if you see, I have a list, and I have a list of numbers 1, 4, 5, 6. I'm going to give you first sample, then I'm going to explain you what I'm doing. Okay, so if I execute this one, see what happens. 1, 4, 6, 7. It is printing one by one. Suppose we have two numbers, x is equal to 10, y is equal to 20, z equal to x y. So you see that it is multiplying. So this is an example. What and all things can we do with the with the program. So if you want to do some calculation, you follow this kind of method. If you want to walk through something, you use something like this. Or if you want to print something, you do something like that. Any question before I proceed?
Sir, I want to know that why you have written like print 1 and print 2 in this.
For example, suppose you have list of name. So what I can say is, you see that? So it is like this.
Yeah.
So if you want to do something, suppose you have stored all these individuals in a place.
Sir, I have a doubt. Rather than writing print name 0 and name 1, we can also write it as a in a array format, right?
Yeah, this is a list. Actually, array list. There are many. I did not talk about the construct here. I'm just showing you how it happens. I am going to talk about each and every construct separately. But I just wanted to show you as an example what generally we do in a program. We either print something, we either do some calculations, either we loop through something. This is how we do it. For example, if I want to write a table, okay, table of, let's say, 10 for, okay, so it is a table of 10. You see that?
Yes, sir.
Okay,
Shiv has a question.
I just want to know the difference between using the return statement and a print when doing functions.
Okay, I'll talk about it.
Okay,
So
thank you.
right now, I will walk you through all the constructs one by one. But I want to show you that generally what we do in a programming language, either we do calculations. Technically, we do all calculations. But the calculation storage may differ or calculation outcome may differ. For example, here we stored just a number. So if you want to store a number, you store it like this. But if you want to print a table, you need to make it walk over something. That walk over something is for using a for loop. Saying for I is equal to 1 to n. Technically, if I want to translate in my head, it will say for I is equal to 0 until 9. So Python usually starts from 0. So when you say 10, it actually means from 0 to 9. And that is where the difference between programming language to programming language happens. Okay, so now if you see the outcome of this for loop, for I is equal to from 0 to 9, you can see that the first character I'm printing is I, and in the end, I'm just printing a table. So this is just, suppose somebody says, I want to write a table, I want to print a table of say 10. If you change the table to 11, okay, so the table changes. So this is the advantage of using a programming language. If something is logical, something is writable on a paper, it adheres to a logic, you actually can make a program out of it. And that is the foundation of programming. You cannot do random things here that computer will think something out of the blue and start creating it. Even if you are getting something out of it randomly, you still have to use some algorithm, some logic here. Right now, our logic is so simple that it's mundane. We just want to create a table of 10 or 11 or 20. So you don't want to write again. One option is you just write print 1 multiplied by 10 equal to 10. One option is this, and you keep doing it. Okay, and you say 2, and you say 20. Correct? It's very methodical, and you can do it. And sorry. One option is this. Another option is this. Both are going to print the similar thing. I will put a blank here. You see that? It's going to give you more or less similar. If I change the number to 10, it's going to give you the same thing. You're getting the same output. But it's repeatable. Here, I could do it in 2 lines. Here, I am doing it in more than 10 lines. If I have to do it for 10. So this is how we use construct. We go from construct 1 to another construct. And construct is just a syntax. Suppose you want to print something on the screen, you use print statement. Suppose you want to send it to printer, you send it to printer, the command will have something like printer or something. If you want to create a sound blast out of this text. You execute some sound related construct. But technically, a programming language, the basic, will give you a way to store a number. A number can be fractional. A number can be integer. Number can be very small, or a number can be very large. But remember one thing, everything has a limit. You cannot say that this is the number I want to store. And let's see what happens. Let us see what it does. Okay, so I will ignore this code for some time so that it doesn't confuse you, and see what happens. But it says 2e raised to the power 109. It cannot store a number like this, but it is still genuine. But what happens is if you have 9 in between, see what happens. It will not be able to tell you that I am precise here. The precision is lost. So in order to help you, support you, it will still try to store a number. But how about if I add some more zeros on it, and let's see what happens. It will keep on updating this number, but you're going to lose the possibility of storing accurate number. Correct? So that is why, however, if I put this in a double quote, so let's start with simple thing. Okay, let's say we are not calculating anything at all. We're just printing it. And see what happens. It remembers the number as is. But when you start to do calculation of it, it's going to lose the precision. So here it has used a different mechanism to store, and here it has used different mechanism to calculate. So when you calculate two numbers, calculation with two numbers, it has a limit. And maybe in another session, I will explain you why there is a limit and how there is a limit. Even if I ask you to remember a number of 100 digits, you're going to forget about it. That is because you are having a limit. And by the way, that limit is because of you. There is no limit to store, remember a number. Now, suppose you want to do calculation. If I suggest plus x, will it work? See what happens. Because computer doesn't allow you to do the calculations, because there is a limit on its side. Not that we cannot do it. Not that we cannot do it. We actually have some softwares which gives you similar programming language like Mathematica, where the number of digits can be up to 50,000, 60,000 digits, 70,000 digits, and it will give you a precise calculation, a very precise calculation. How they did this? They actually wrote a program which will simulate you the calculations, a large number calculation. Anyway, so now you can see, if you want to print something, you use print. You want to store something, you use X. But what can you store with X? You can store it as a text as well. You can store a fraction number as well. And you can store, I think these are the three foundations ones. Then they will start be a complex numbers in terms of what you want to store. Suppose you want to store x, c, coordinate system as equal to 1, 1. Will it store? Let's see. And if I just say print xc, it prints. So it understands. And if I add one more comma, it stores, it remembers. So this is a different data type, and all these are data types. So this is the x, which is storing a fraction number. This is the y, which is storing a very large number. But technically, when it stores inside, it is actually going to throw it away. You're going to keep only some part of it. But what if I keep it in a double quote? Then it will store. But it won't be able to do calculation, because this is a string now. You cannot multiply psi by deep. You cannot do this. You cannot say psi multiply by deep. You can't do that. And that's why you have to write a logic. If you want to store number without losing its precision, you have to store it in the form of, and you have to write your own logic to do multiplication. Anyway, coming back to the types. Now, another type is list. Okay. Another type is map, where we are going to say x colon 10 comma y colon 40. So this is one way. Sorry. This is one way. Now, how do you, if I print Excel, I will see this thing. But if I print XM, I will see this thing. And you know what happened? It has taken this value y here and placed it here. So what I'm going to do is, I'm going to call it x3 and y3. So now x3 is not defined. You see that? So now it's okay. So this is called map. This is the map. Okay, this is the list.
What do you mean by map?
Yeah, I'm going to talk about it one by one. I'm just, first of all, making them aware of that there are 10,000 ways of storing anything. Now, this is when you are storing numbers. To answer your question, map is just, you are actually, suppose if I write XM, you see that if I just say, I think this will allow me. It needs double quote. Yeah, you see that. So basically, it is storing 10 or 40 as a key of XM. So if there is a key y3, if there is a key x3, and I want to check what is x3 and what is y3, and I print it, you will see different values. How do I prove my point? If I say XM dot keys, I think this should work. You see that? If I ignore the first part, not to confuse you, it is a dictionary. So if you open your dictionary, what do? You have a name and a meaning, and you can have multiple meaning as well. So technically, if you want to write like this, that's okay. That's okay. So if you want to see what is that I have stored at this point, it will say this. But on the other hand, if I say y, it will say this. But right now, don't get baffled with so many constructs. Idea is, as you go deeper in the experience, you will find different types of or different ways of storing data. And when we have large set of data, we usually call it data structure. Because
Excuse me, sir.
mhm.
Sir, I want to ask a question regarding what data type is usually used in Python for storing a data.
These are the data types we are using for storing data. So for example, name. Okay. And what's Himanshu's second name? Sharma?
Himanshi Bhatt.
But sorry. Okay. So this is and address. And for easy, we will just call it Bharat. Okay. And if you want to know, I won't say age, she's going to be unhappy. I will just say class. Okay. And I will select it. Isn't 10th, I suppose?
9.
9. So this is one data structure. And if I say, what is an address? So this is how this whole structure is created. So then you can say, what is name? Imagine. So when what happened is eventually, this is just one user. So if all of you have Insta, they are, when you log into your profile, you will find your name and address or map location or preferences, all those things are actually stored in this construct, dictionary. So when you store, you can actually store images here as well. You can store images, just not numbers. There is no limit. For example, if I say bank accounts, and I will say, let's say 1, 2, 3. These are the passwords of a bank account. Is it, Himanji? So this is the password. There are 3 bank accounts. Each has a password. So when you log into your account, this kind of structure is formed on their side. But now there are millions of people, billions of people. So what they usually do it, they store in a database. The database will be carrying this structure as one row or multiple rows, depends. This is basically called JSON. Okay, are you getting my question? Are you getting anybody questions, please?
Does anyone have a question, or you're getting everything?
Sir, I have.
Now, what's JSON?
What happened is about 20-30 years back, JavaScript was formed. At the time, there used to be notation of storing this kind of information in the form of an XML. So for example, if you see XML example, it will something like this. I could show. Wow, they don't have a sample. Okay, so this is something like this. Note, start, note, end. To, from, heading, something like that. But this is too verbose, correct? They have too much of text in it, more than the original text they want to store in it. They have too much of text. It's almost, the notation has taken more storage than actually the original types. So what people did, they challenged this in this form. For example, this one. If I have to store this one, I will just call it like this. And I'm going to call it not equal to this. You see the point? And I might store it, what is this? 2 colon. And it is not the right model. I'm just showing you possible reduction.
This is a dictionary?
Yes, this is a dictionary, but I'm going to
Okay.
talk about what is JSON. Just hold a sec. So now you can see that amount of storage required by the original notation, which was started by Microsoft. I think so, Microsoft, or they stole it from somewhere. The amount of characters required here and the amount of characters required here are drastically different. At least the notation here is not overwhelming. Correct? It's not bulged just because of the notation. For example, somebody come up with a name, something like this, which is very verbose. Then this whole thing has to be repeated at the end as well. And then you have to put it in the end as well, correct? That makes things very heavy, and the data is this tiny, and this notation is taking too much of space. So when the JavaScript started, we didn't have much bandwidth available at the time. So they came with a notification for the JavaScript object notification. So this is technically a dictionary, but is also an object. What is an object? It just structured information. Could be binary, could be text. What you can read is actually text, and what you cannot read, something like that, ABC, or actually I do not want to go into that, but let's say I am pretty sure people would have understood what this line means, correct? Did you get it? What this line means? Anybody can translate this? Cannot, correct? Because you need to understand what is this gibberish. Instead, if I write like this, you can read it. So if somebody translates your text into binary and gives you this, or somebody gives you text, you can read it. For the human readability, we have text available, but when you are storing in a system, we prefer to store in a very something which takes less space. And we'll talk about it maybe in the next sessions.
Gatik has a question. Yes, Gatik. Gatik, are you there?
Sir, I actually wanted to ask a question. What primitive data type is used in Python usually?
What?
Sir, my question is what primitive data type is used in Python usually?
These are primitives, whatever you're saying. A number in a fraction form, a string, or a number in a integer
Sir,
form.
number.
Just simple. But you also have other options, Boolean,
Yes, sir.
which is equal to true or false.
So Boolean is usually used for true and false, right?
Yeah. So when you have to say yes or no, then you use Boolean. When you say how many, then you use this. So technically we have 4, 5. There might be some more, but in general.
How would we use how many for Boolean?
What do you mean?
You said how many, but
Yeah,
using Boolean,
number.
how
So
can
if
we
you have to store how many, you will say 1, 2, 3, 4. Then you use the integer data type or something like that. But if you have to store yes or no only, suppose somebody says, okay, if somebody says, let me start a new. Somebody wants to store the information, promoted. You won't say 1. Is this guy promoted? You say 1 or 100. Will you say that?
No, it's not easily
You will say
understandable.
true. You will say true. Or whatever. I want to.
That means instead of true, can we use yes or no?
And the point here is that they have made up a mind that they want to use true and false. But in some programming language, they allow yes and no as well. So technically, most of the programming language will stick to true and false. You might find a small variation that they make it this way. And remember one thing, most of the programming languages respect the case sensitivity. So if you are using small case, or you can see that it recognizes this in a purple color because it is a construct of the programming language. It is accepted by the programming language at its own friendly thing. It did not color this one because it doesn't understand what is this, but it understands this. So it is coloring it purple, but not true. So it means true in first character caps is the right way of storing true and not this one. So if I store this way, it's going to cry. But on the other hand, if I do this, it's going to cry. The only thing which we should understand is if you do not abide by the programming language construct, when I'm using the word construct, I am talking about semantics.
That means the way it has to be written.
Case sensitivity. So you cannot say true is equal to promoted. You can't do that.
It has to be on the left side. Promoted is equal to.
Yeah. So because you are assigning. Now this is one is assigning. But what if you want to check? Correct? How do you do that? If let's run it.
You forgot the O.
Oh. See that? He got promoted. The funny thing about you see the single, equal, and double equal. Here, when we want to validate, so we have two different kind of operations. One is a numerical application, numerical. Another is Boolean. The Boolean is actually a check. Okay, this is mathematical. Actually, both are mathematical, but technically to make it simpler. So when you want to check something, you do that. And Python gives you many different ways of checking that. For example, if I don't write this and I say if promoted and let's run it, see what happens. We got it. And if I make it false, it won't print. Then we will say else is not promoted. If I say true, he is promoted. So this is the power of programming language. But why do you want to do all these things? I can do all this calculation in my head. Why do I need this? Now what happened is when you're writing a program which is managing millions of people, for example, you clicked something on your screen and you clicked at a particular point, or you clicked on a button and the button is, do you want to subscribe to this one? Yes or no? You're going to press something yes, somewhere no. That yes or no will be stored somewhere as your preference when you're creating your account. But here, this is simple. This looks simple. But imagine you have, if you look at Infosys, it has over 2 million, 2 million, or 200,000 or 300,000 or 400,000 employees. You have to maintain a register of 200,000 people. But you will not be able to calculate something at large, that how many people got promoted, how many didn't get promoted. That kind of information, you need to walk through the data. And if you want to do it on paper, you can do it. But then it becomes a government office where you go and stand in the line for hours, whether you got promoted or you got salary or not. Got it? Before I proceed, any question?
Gatak, do you have
Okay.
any questions? He is the one who has most questions.
No, actually understood it.
Tanmay, you had a question and you didn't get an opportunity to ask. Tanmay?
Yeah.
Yes, beta, you had a question. You didn't get a chance to ask.
No, I was also asking that what was the code that she wrote for the sir.
Okay.
Like the print one, I was asking, but now it is cleared.
Okay. Somebody asked about the return of the function. So we'll talk about it when we talk about the function. But in general, first of all, you need to absorb the point that you have different constructs. And when you collect, and if you remember, some of you said that it's a series of instructions, and this is an instruction. This is an instruction. This is an instruction, like that. So if you want to say, if somebody is promoted and his salary is also increased and his salary, so you can see that now I am trying to put forward a logic of what we actually talk to people in the form of some kind of instructions here. Now, imagine we did not use the word promoted and we call it P. P and we just call it S. And it's if P and S, what will happen is the poor guy who's going to read your code, if you're not in office, he's going to cry. Because poor guy doesn't know what is P and what is S. That's why it is always wise to name the variables. So these are actually variables. I'm giving you new words here. This is actually a variable. This is all it is trying to tell you is you are giving it a reference in the RAM, in the memory for certain information. That variable can be of type Boolean. This is the data type Boolean, or type integer, or type JSON. This is JSON, Java script object notification, not just notation. Yeah. And certain types like string. So these are data types. How do we know? Let's check. We say print type of promoted. Again, I forgot. That's it. Class Boolean. And it used the word class. We'll talk about it. And if I check table, let's see what it says about table. Int. It has we had a variable xc. Let's see. Tuple. You can say tuple is just a set of numbers. It just I will not use the word set here because set has a very specific meaning. I will just call it a tuple where some numbers are grouped together. It's like 2-3 people talking to each other. Okay, names. List. And how do you denote? By square brackets, by a round curly bracket, by a round bracket, like that. Now let's see what is XM. Dictionary. And dictionary is very close to set. Very close to set. How many of you actually understand what is a set? Do you know what is a set?
It is a collection of numbers or anything like objects or a group.
Yes. Set is just a set, but it has some more qualities on the top of it. Intersection. Correct? You have this minus operation on the top of it. You have basically OR operator on the top of it. We will, if we get a chance, we could show a sample. But remember one thing. One thing I did in my entire education, I started using desktop around 1988. Whatever I studied in my class, I created a program out of it. So whatever a question will say, if the distance, if the velocity, or suppose you might be seeing this kind of question. I don't know how many of you have seen this one. Velocity is equal to initial speed plus acceleration multiplied by time. So if I have this actual value of initial speed and we call it u, I don't know if you understand that term. U is equal to 10 and acceleration is equal to 20 or 29 and time is equal to 10 seconds. Print velocity, and we like to beautify it. Double quotes. Why do I use this? Okay, so you see that. How many of you have heard of this kind of equation? V is equal to U plus AT. Anyone who has seen this?
Yes.
Good. Who else? So equations like which are there in the physics, which is S is equal to ut plus half gt square. All these things you can easily calculate because if you have u, you have t, you have half gt square, you can calculate the distance traveled. My point is, don't stick to the equation. They may be new for you. So people who are there in the 7th or 8th standard might not have seen it. But idea is, whatever you see in your mathematics, whatever you see in your science book, you actually can test it here. So all you have to do is, you have to log into your laptop, or even you don't have to install anything. You can just go online. I will show you the tools and you can run your program and check it. You will get two benefits. You will get in-depth understanding of the programming language, and you will get in-depth understanding of what actually you're doing in your class. So it will double the job. So not only you're going to learn programming, you're going to understand your class as well. Because sometimes you might find the calculations in the class which was shown to you many times is not correct. For example, hypotenuse is equal to square root of a square, sorry, plus b square. Have you seen this one? Anyone?
Pythagoras?
Sorry?
Pythagoras?
Yes, Pythagoras. So, how long it will take you to calculate this? Only thing is, now we are entering into the world of functions, which are mathematical functions. So far, what you are doing is just playing with the numbers. For example, suppose, let me comment this out. If I say x is equal to 1.0, print, actually 1, okay, print integer of xx. See what happens. And I think I should start a new row. See what happens. It doesn't print anything. That's funny. Should it not? Ah, it prints. Sorry. So it prints 1. So if I say 2, it prints 2. But what it does, it throws the fractional part of it. So all this you see is technically, or if I say a square, if this is exist, it's going to cry. Now what happened is we are going to say math dot. Now here we start a new kind of world where we say import math. And I think this is the function. Yes. So this is the square root of, let us say if I say 4. What is the square root of 4? 2. But the funny thing is you're showing the fractional value. If you don't want fraction value, just say int. What did I do? One more bracket. One more bracket. Ah. How many of you understood what I did here? Nothing.
You put the int thing to make it
Yes.
a full whole number, and you
This
use
is int. What is this thing?
Oh, this is import, so you get extra because
Yes.
Python
Yes.
doesn't allow you to use every function, right?
Yes. So what I'm trying to tell you here is the programming language will give you certain set of capabilities which is very foundational. Multiplying numbers, adding, deleting, something like that. It won't teach you how to do advanced calculations. And when you reach that level, you will have to rely on the libraries built to support Python or built for a capability. Now, one of you guys asked me a question, what is the function? And I'm going to give you a closure after that. Suppose you want to do a certain activity all the time. So you're going to say diff function done. And you expect a parameter name. You print.
Arshnur, what's your question?
Yeah, my question was then, so I added into it. It removed the integer from behind after the decimal point. Does the int function remove the integer or it rounded off?
Give me an example. What do you want to say?
Like you added into the print command you used. Okay. Then you said the square of root of I guess 1.2. Then you added int. The square root of 1.4, it would be without the int, it would have the integer, the decimal point. I got confused. Yeah.
Okay, so let's try this thing. I will say 2.
Let me give you an example. Let me think of it.
Okay.
I got confused.
That's okay. So let's see what happens here. What do you get? 0. You get a 0. Correct? Because integer part of this is 0. Technically it is this. It will chop it off. So if I say 0.5, it will be 0. If I say 0.99, it will be 0. Oh, it has to be math. Here, this is an advanced function, so I had to invoke math, sorry. So the seal and int, they will behave differently. You can see that. The seal is printing the sale is printing 1, int is printing 0. Technically, if you look at my roof, that's a ceiling. So if I'm close to this thing, it's a ceiling. If I just want to chop it off, it'll give me the floor. So int is actually the chopped version of the integer part. If it was 10.99, see what happens. The int will give you 10 because it will just chop off this thing. And sale will give you the upper part of it, which is the closest here, which is the closest ceiling. So if I have kept like 49, it is still trying to give you the bigger one. But if it is 30, it is still giving you ceiling. You see that? So closest integer number on the higher side is ceil, and the closest integer on the lower side is int. So int is chop, give me the left part. Ceil is give me the upper number just ahead of it. So if I make it 0.01, still gives me 11. Because it is giving you the bigger number than this, but still an integer. But this one is saying, I don't care, I just want the number, integer. Similar to this, you can get the fractional part of a number as well. Similar to this, you can get the integer part of it. This is the fractional part, and this is the integer part. Now, we will talk about the function. So suppose we look at the code here. Any question?
I think functions we should take in next class because it's way too advanced for everyone.
I just want to answer.
Some of them may have done it
I
already.
got a question.
Mhm.
Okay. See where you made this function, this f, where you're printing it, and where you put the curly brackets. I've never seen. What is it? What is this?
Yeah, I was
Where you
waiting
put
for
the
somebody to ask this question. That's the reason I deliberately have been using it. Okay.
Yeah.
So what happened here is, if I don't do f here, okay, I start a new one. If I say print this is a sample name, I look above, I define name is equal to sign. Now see what happens. Correct? Now if I copy this line and just put an f in front of it, you got it?
Oh, I see. Yeah. It makes the name into, it takes the value of name.
Yes, it places the value of this thing, and it doesn't have to be his salary is number multiplied by. You see that? So not only it places the value of it, it can do little bit of calculation. I will not call it complex calculations. It can do little bit of calculations. But technically whatever resides in this is being calculated. So this is the plain text, but this is a formatted text, and that's why the F is there. And there are many ways of doing the same thing. There are many ways of doing the same thing. You actually can even do a lot more than what I'm showing you right now. Suppose I want to put a dot here and put it in a decimal format. I can put some construct here, it will show in a decimal format. So the crux of the matter is they are similar thing, but one allows you to replace a variable and calculate something, little bit of calculation, and actually place it here. Any other question? I know we have spent more than 1.5 hours.
Yes, we need to wrap up now.
Okay.
Can you share the link where we can run the program?
Yeah. So now you don't have to wait for me to give you something. All you have to do is, even I went to Google. I used to do that when my desktop was not good enough in the beginning. But if you go search online Python coding platforms, you can search it yourself, and you don't need a desktop for that. You can do it from your phone, you can do it from your iPad, you can do it from your laptop. It doesn't matter. The advantage you're going to get is, if you are sitting on a couch, you want to practice some little bit of coding, you just go to some kind of online Python online practice, look for anything. Let's say not this one. This
The
one.
one you were using, can we use that?
Oh, I was using this thing. This is Anaconda on my desktop. This is called Jupiter.
Oh, okay. So it's not an
So-
online.
So the one I was using earlier, this one is actually showing you.
I have the link for it.
You got it?
I got a link for it. A compiler.
Can you share it or
Yeah,
share?
anything.
Yeah, yeah.
Put it in the group, in the WhatsApp group.
Okay.
Don't go for these ones. Yeah, one compiler. It's okay. Whichever you guys feel comfortable with.
Yep, I've shared it in the group.
Thank you,
Good.
Arshia.
So, but remember one thing, guys. The reason I did not want to give you anything, do not log in. I will strongly recommend all of you, do not take any site which requires you to log in at all. Always try to go to the site which does not require your login credential, because they're tracking you. They will create a small kind of a software which you will be attracted towards. It's like a sink. They call it a sink. And you will be attracted. That's the reason I was hesitant to give you anything. Like on one line compiler is there, or online something is there. There are many. Like this didn't ask me any password. Okay. This didn't ask me any password. I can just type here. So if you have to log in, please don't do that. Okay.
Thank you so much. We will be wrapping for today. So whatever questions anybody has, put it on the group and we will solve those questions next week. And I think we should be practicing now so that we can understand the next lesson. Thank you.
As an exercise, all I'm going to say is watch this video again, and whatever I tried to create, if you can just create those again, don't try to create everything. Just try to create a variable, store in a variable, try to print it. We used to print, I give an example. We used to, when we started, we used to print like this. We came to know that we can make a star out of it. And can you imagine this? We did this kind of funny thing we did. And we were funny in our initial stages, but at the time there was no books or stuff which we had access to. We used to do this thing as well, and it is no brainer. And if I print this thing, it's going to print this thing. That's it. Nothing funky about it. No technicality. Just make your own. You must have seen a lot of icons. People are start throwing these icons and they're using text to create some kind of stuff. Go create one. You make a temple, make something, make a. If I just repeat this thing, and see, I'm going to make a diamond out of it. Brilliant. No rocket science. Okay. So I will stop sharing now. And I will make you dear. Make host. Okay. Okay, guys. Any questions? Okay, cool then.